Hello, hello. Sorry for the slight late start then. Technical issues are a requirement, I believe, of doing talks. So, including my clicker not working. So, clicker getting too active now. So my name is Joe Glombek. I'm a .NET developer at Bump Digital in the UK, and I'm an MVP of the open source CMS Umbraco. You can find me on my website, my blog, joe.gl, or Twitter at Joe Glombek. So today we're going to be talking about why am I being such a git about it. But let's start really simply. First of all, what is Git? Git is the most popular. Git is the most popular source control management system. It can ensure your code is backed up, versioned, and shareable to other developers. But used properly, it can be so much more. So it can help ease complex processes such as release management, feature development, and people working concurrently. But I can be a bit of a git about it. I'm really fussy about how people use Git, and I think that's a good thing. I've worked with a fair few organizations and development teams over the years, and poor Git utilization is more common than you might think. People use it more as a dumping ground for code rather than a well-managed archive of software, which we want it to be. So today we're going to be looking at 5 simple tips, which with any luck will improve your Git practice. I should have done some admin at the beginning. Feel free to post any questions or comments. You might disagree with some of the things I say. Feel free to pop them in Discord or any way you see fit, and we'll discuss them as we go along. There's not too many of us here today, so we can have a nice friendly chat, a very one-sided chat, but we can have a chat. So this isn't one of the 5, but there are more organizations than you'd think out there who aren't using version control yet. So version control is not the same as a backup, and if you've been emailing code around to a colleague, you're probably doing it wrong. You're definitely doing it wrong. So, oh dear, my imagery is not looking good today. I think it's having a hissy fit. I've had many technical issues so far today. So why did the developer not want to use Git? Because they were scared of committing to it. But for all the reasons I gave previously, source control really is essential in today's development. None of my icons and images are loading. Let's try this with a bit of a hard refresh. But while I wait for my speaker notes to load, your options for version control are numerous. Mercurial, Team Foundation version control, and Subversion are all examples of version control software. But Git has really taken off as the industry standard in the software world. And I'd recommend it for that on its own. There's no point teaching your team a version control system which may become or is already redundant. So now we've settled on Git, let's get some of the confusion surrounding Git and brand names sorted. Although they all sound similar, these things sound very differently. So Git is the version control software. The alternatives to this are the ones we just looked at on the previous slide, but all those other ones are incompatible with Git. Then we move on to the next column of Git hosting. So GitHub, GitLab, etc. are version control hosting providers. They run the Git software in the cloud to help us run Git with a distributed team. And finally, on the right-hand side, we've got our Git clients. So confusingly, GitHub, the host, has a client called GitHub Desktop, the client, to interact with it. But also you've got things like Git Kraken, Git extensions, and of course the Git command line as well. And they're used to interact with our local Git software and push those changes up to the host. And getting started with Git is 100% free as well. all of these you get unlimited private repositories. All of these popular Git hosts, you get unlimited private repositories, and you pay a little extra if you want some extra sort of team management features and extra build minutes and deploy minutes and that sort of thing. But all of these options have a fantastic free tier. So getting started with Git is really price is no object. And a quick note on the Git clients that I'll be using in this demo. So Git clients are how you interact with your remotely hosted Git repository, if you remember, and there are lots and lots and lots of options out there. But I strongly suggest using one that can render a really good Git graph or Git tree. The client built into Visual Studio or GitHub Desktop are fantastic for getting started for beginners, but you'll soon find them inadequate on their own as you need to do more complicated things or diagnose merging issues. So personally, I'm a really big fan of the way Gitkraken works and the really useful tree of the Git history that Gitkraken provides. For me, the time saved by using Gitkraken easily outweighs the costs. And Gitkraken is the one I use, so that's what you'll see a lot of is examples in my demo. But if it's more your style, there is a fantastic Git graph extension for VS Code by Michael Hutchinson, and it's a very good open source alternative. So that's another option as well. Visual Git clients really reduce the barrier to entry, but I'm not saying that using the Git via the command line is out either. Knowing how to interact with Git in its simplest form is definitely a skill worth having, but please use a visual tool as well, just to double check, because Git experts get it wrong too, right? And it's much easier to fix issues the earlier they're caught. And I've seen it so many times where a diehard command line Git user has come to me looking for help with their Git issues, and it's been just such a simple fix as soon as you open it up in a visual tool. And in fact, as you can see in the screenshot here, both Gitkraken and VS Code, with the help of Gitgraph, allow you to interact via the terminal while also rendering the Git tree. So you can still use your CLI methods, but I would really recommend just having that tree rendered at the same time. It can save so many issues. It's definitely worth it. So as I said, I'll be providing examples with Gitkraken and the command line, but methods are very similar in other Git clients. It's just I happen to use Gitkraken myself. So let's move on to tip number 1. Commit messaging is everything. So here's a comic from the brilliant XKCD. As a project drags on, my commit messages get less and less informative, going from something as descriptive as created main loop and timing control into the absolute anarchy that is my hands are typing words, hands. And I'd like to say it's just in a joke and a comic strip, but it can be all too real. So I feel for you here, Dennis. Investigating an issue and by scanning through useful commit messages in Git. And in that Git history, we've got test, 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 bump, bump, translation fix, which is almost a reasonable Git commit message. We've got bump, bump again, bump, and bump. So imagine being in a situation like Dennis's. So I've rendered the tree up on the right-hand side there. Imagine being in Dennis's situation and you've discovered a bug and you can't find the commit where it was likely introduced. So where do you even start looking in a history like this? Or perhaps you see something odd in the code base. There's no comment that explains why something's using this obscure method. Blame annotate, so you use the blame or annotate tool to see who changed it and why. So you find out that this commit was done by Andy and he's on holiday though this week, and his commit message just says test. It's a little bit of a blocker. Or alternatively, some piece of code has changed since you last saw it. You're not quite sure why. You prefer to do it a different way. You could just revert it to how you'd like doing it. But maybe it was changed for a reason. So you fire up the blame tool again. you see a commit message fixes date formatting issue in Chrome, and suddenly the sort of obscure bit of code you've been looking at suddenly seems to make a bit more sense. So you better leave it as is. So you've been saved by a good commit message there. It sounds like a contrived example, but I have seen this before, where two developers are just committing the alternate solution of the method they prefer to do things, not straight after each other, but give a few months in between. You come back to it, you come back and look at the Git tree, and you can see that people have just been doing and undoing the bug fixes. So it sounds obscure, but it does happen. So some people tell you that a good commit message should be written as if answering the question, what does this commit do? And that is fantastic advice. You can also start your commit messages with verbs like fixes, reverts, or integrates, and that's good practice too. But these aren't enough, right? So fixes bugs, reverts broken changes, they're still useless commit messages. They still don't tell us what they're doing. So detail is where detail, that's where that comes in. So Gitkraken and many other Git clients give you two fields for your commit messages. They give you a title and a description or body. It's best practice to keep your title nice and short so that it can be easily read in whatever situation you're in. Gitkraken recommends that maximum length of 72 characters. It doesn't enforce it, it just recommends it. But then you can add so much more detail in the description field. So I've rewritten some of the commit messages from the previous slide, but giving it the sort of what I feel is about the right level of detail. So I've got fixes date formatting issue in Chrome, and there's the title, and then there's the body. Chrome always assumes the month, day format, no matter what the locale the browser is set to. It doesn't. I made that up. It's not like that. Or how about reverts the new paytastic checkout flow? Customer has changed their mind and wants to revert to using legacy cart. Fantastic. So you've got a brief overview of what's going on at the top, and then you've got a little bit more detail as to why this happened. And then moving on from integrates API we had on the previous slide, integrates SMS API. Okay, so a little bit more detail in the description and the title, sorry, and then we've gone and said sending an SMS to customer when their order ships using the simple SMS sender API. So we've added loads more detail into the body there. So it just makes it absolutely clear what you've been doing. Your choice of Git client isn't an excuse either. So if you're using a Git client that doesn't split out the title and description or title and body fields, you can just stick a new line in there, and that will split it out automatically in other Git clients and in services like GitHub, GitLab, etc. You can also do it on the command line by just passing in two message parameters. So the first one will end up being your title, the second one will end up being your description. If you use a ticketing system or to-do list, it sometimes helps to include the title of the item in your commit, and an ID or link to the initial issue can prove very, very useful. So Gitkraken and other Git clients let you hook up your issue tracker to your Git repos, so you can automatically stick an issue number into the branch name, and therefore when you merge that branch, the issue number will automatically be in that body description of the merge commit. Now, if you want to enforce some of these Git committing rules, it might be worth looking into gitlint. I can't even speak. I put a short link down the bottom there as well, so that's go.joe.gl/gitlint. And gitlint validates Git messages meet certain rules. So you can run it locally with a Git tool as it validates every commit that you do. Sorry, as a Git, so you can set that up as a Git hook, validating every commit you do, but also as a GitHub action, for example, to check each commit in a pull request. So for me, gitlint feels a little bit heavy-handed, but if you're the sort of person who needs their hand forced, you've got a team who are particularly lax in this area, then this can be a great way to do it. So here's the setup process for running Git locally. You need Python installed, and be sure to add Python to path so you can use it easily on the command line. That's just a checkbox with the Windows installer. Then use pip to install gitlint. And at this point, you can just run gitlint and that will lint your last git commit message. But we can do better. We can automate it by installing it as a git hook. So gitlint install hook will do the git hook stuff for you, and it will run automatically on every commit you do. And then you'll see the git error message on the right if you do something that violates the rules you forgot set up. So that comes with a load of default rules, but you can change the git linting rules, and you can do that just by generating the gitlint config, which is just a command line from gitlint, and then you can open that in the editor of your choosing. So I've opened it in code to edit the rules in there. I've got a few examples of those coming up as well, so you can see what sort of things can be done. We can also set gitlint to run as one of the checks you see on a GitHub pull request by creating an action. So the following YAML will grab the code from a pull request, install and run gitlint on every commit that was in that branch that you're merging. This setup will also utilize the .gitlint file that we created with the gitlint config in running locally. I've stuck this configuration on my blog as well, which is at joe.gl. All of these articles are the top ones, so they should be nice and easy to find. And that's how you set it up as a GitHub action. Here's a very small subset of some of the useful rules you can find to configure gitlint. So adding these individual rules to your gitlint file will, first of all, set the maximum length of a commit title to 72 characters to match Gitkraken's recommendation there. We can also set the minimum length. So here I've set it to 5 because I want to stop people committing the word bump as a commit message. You can also disallow work in progress commits. This one to me only makes sense when running the linter on a pull request rather than running it for every commit. And we'll come on to why I like work in progress commits later. We can also ensure that a commit description contains a reference to a GitHub issue number, for example, with a fixes prefix. So I've just got a regex match there on the body. Also, we can validate a user is committing with their company email address, which I'm definitely very guilty of committing with my personal email address a lot of the time. We can enforce conventional commits, which is a process that differs from what I'm going to talk to you about today. But if you're using that, then you can lint it as well, which is fantastic. So moving on from commit messages on to tip number 2, and that is to commit and push little and often. I've seen lots of different tactics when it comes to how often people commit, but the most persuasive argument I've heard is for little and often. Because don't forget that Git acts as a backup of your work in progress too. There's no point only committing when something is feature complete. What happens if your hard disk drive packs up overnight, or you're off sick tomorrow and nobody else is there to pick up your work? It's far more useful to have a partially complete work committed and pushed than not. Although it's generally good practice to ensure your commit is in a buildable state. I say it's okay if you prefix your commit with WIP for work in progress, and then they don't have to be able to build. And we'll tidy up those work in progress commits later. The other benefit of committing little and often is that if you've got several tiny commits, you can use those to more easily revert unwanted pieces of functionality. While it can be a real pain to pull out a small chunk of code from a bigger commit. So here I've got an example Git tree. So initially I made a commit on my Git talk branch to write the talk, then create the presentation, change the color scheme to green on red, reorder the slides, which I was considering doing those as one commit because they're both really tiny changes. I was just doing it at the last minute, but I didn't. I split them out into 2, thought I've got to follow my own rules. Merged the Git talk branch in, and then realized I'd made a fatal error. Perhaps changing the color scheme to green text on a red background was a a little bit much, especially as I'm red green colorblind. So I took that that little change and just reverted that one commit. If I had done my 2 commits, my reorder slides and my color scheme change commit as 1 commit, it would have been a bit more of a pain to revert it. And it might have been less clear which commit I had to revert. So these little and often commits can really help in that sort of situation. But don't all these little and often commits start to make a racket after a while? Do you see what I did there? That's where squash and amend comes in. So as I mentioned, I'm a big fan of work in progress commit, WIP commits at the end of a day. But come tomorrow morning, and I've finished that small segment of work off, I don't want to commit 2 commits. I don't want a work in progress restyle footer and a restyle footer complete commit. So I can actually use a feature called amend to amend my work in progress commit to include all of those changes and then rename that commit from work in progress to restyle footer. And in GitKraken, that's just that simple amend checkbox on the top right of the commit message box. I think I've got there's a flag on the command line. I think I'll show you in a second. And then I've just got that 1 commit. So last night I had a work in progress commit. This morning I've got a restyle footer commit. And that just keeps your tree nice and tidy. There you go. Told you I had that. On the command line, git commit amend, dash amend rather, -m for the message, and your new message goes in there. Atlassian as well actually has a really good tutorial about rewriting Git history from the command line. There's a short link there, go.joe.gl/rewrite-history-commands, if that's of any use to you. So if you want to combine multiple commits though, or you've already committed your second round of changes, so you've already done the work in progress commit and then the completed commit, you can look at squashing those commits to make them smaller and into fewer commits. So here's the example. I've done 2 work in progress commits, in fact, and then I've done my 3rd commit where I've completed that task of restyle footer. And this is done in GitKraken, again, very similar in other Git clients by multi-selecting with your Shift Control key, the one that does multi-select, and right-clicking and saying squash those 3 commits. Now, there are some scenarios when squashing won't be available. And in this case, it might be best not to try and force it, just leave your slightly messy history in that case. Because we don't want to mess it up. But what does the squash actually do? So squash is a method of rewriting history in Git. So essentially it pretends your initial commits never happened and creates a new commit. Creates a new commit. I jumped forward a load of slides then. I don't know what happened there. Where were we? Go all the way back here. Essentially, it pretends your initial commits never happened, then creates a new commit containing all the changes from your previous commits. Really doesn't like that slide. Slide. There we go. Because we're rewriting history, you'll often get a scary warning message when you try to push or have to use the force flag in the command line. Really, though, this is nothing to worry about. The reason we have to force push is because we've already changed the commits. We've changed the commits we've already pushed. So we're rewriting history. So on the left-hand side of the screen here, I've got how our remote server, so that's how a GitHub, GitLab, Bitbucket, DevOps thinks our branch looks once we've pushed. But on the right is how we think the branch looks on our local machine. So after we've done that squash, this is what we're saying, hey, this is what the developed branch looks like now. Since the commits are different, Git wants us to be 100% sure that what we have locally is what we want on the server, hence forcing that overwrite. The only real thing to be wary of here is if anyone else has been working on the same branch, you might overwrite their work too. So it's best to avoid this. We'll come on to a little bit about that in a minute. But also always check for new commits before you push as well, just in case. So in fact, in this example, I've done this squash on the develop branch. Probably not the smartest thing to do if we're sharing this repo with other developers. In fact, I probably want to be doing that on a separate feature branch of the feature restyle header branch, for example. Cool. Then we've got an analogy. Who doesn't love an analogy? So if I'm doing DIY at home, things can get pretty messy with tools and dirt around the place. Before I go to bed, I might do a quick tidy up. But the next day, once I finish that piece of work that I'm doing, all the tools go away, I vacuum up the mess I've made, and I'll definitely have it clean and tidy before I let anyone else in the house. And treat your repos the same, or your branches even the same way. It's okay for them to be a bit messy when you've got things in progress. But as soon as you're finished and you're ready to merge into a shared branch, you ought to tidy it up because nobody wants to see or deal with your messy branch. Someone asked about linking Jira tickets to feature branches. I believe GitKraken does work with Jira, but I haven't used Jira for many years now. But I believe you can. Bitbucket as well, which is very closely tied with Jira because it's all Atlassian stuff. That works really well. They work really, really well together. And Atlassian also have a Git client, but it's not very good. Or wasn't last time I used it. Who's to say? SourceTree. So those link together very well. And what you can actually do if your Git client doesn't support Jira natively, you can go, if you create your branches, for example, in Bitbucket online, and then commit to that branch in your Git client. That works quite well. Has worked in the past. Sorry, just jumped back. I wasn't quite on it with that question there. But one thing to note, though, so back onto squashing. One thing to note is don't squash your mistakes. So your mistakes and your reworkings, they tell a story. It could provide a valuable explanation to a future developer, and it also documents your mistakes and learnings. So only use your amend and squash to tidy up and not to cover up, not to sweep under the rug. We don't want that. Moving on to tip number 4, and that is to use a branching strategy or flow. There are many branching strategies out there, and I don't really mind which one you use. That's the least opinionated part of my talk. My personal favourites are GitHub Flow and Common Flow, or a combination of the two more often than not, but there are many more. It's worth noting GitHub Flow and GitLab Flow, they're not specific to their respective hosts. So you can use GitHub Flow on GitLab if you want, or GitLab Flow on GitHub, or any of them anywhere. But those hosts do sometimes make it easier to follow their pattern. So if you've got a repo on GitHub Flow, a good starting place. If you've got a repo on GitHub, sorry, a good starting place is GitHub Flow. But you can use them any way you like. It's just sometimes the UI is a bit more geared up for their own idea of what the flow should be. Generally, though, all of these flows follow a feature-driven development pattern with a branch for each feature and some sort of notion of the state of a particular release as well, generally using branches or tags. I also like to add further restriction that only one person is committing to any single branch at one time. This covers the situation we were talking about before. If 2 people are working on a feature, then maybe break that down into 2 sub-features rather than having them committing to the same feature branch. And that's really the only way this sort of messy work in progress branch that you tidy up later method, it's the only way that really works. So just to always try to have one person to one branch. But let's look at one of these flows or a couple of these flows, in fact, in a little bit more detail. So let's have a look at GitHub Flow first of all. Put very simply, it involves the creation of a branch in your feature for your feature with a short descriptive name, says GitHub. Then you add your commits to that branch, each commit containing an isolated complete change, unless it's work in progress, but we'll clear them up later, so that's fine. And then you open a pull request. And that pull request is linked to an issue. So on GitHub, it likes to do it that way around. But if you've got the commits linked to an issue, it's a lot easier to find the right issue when you open your pull request. Discuss and review your changes with your colleagues. And once everyone is happy, your pull request is merged into the main branch. And GitHub Flow says that main is always in a deployable state. So if you're doing that merge, you're happy that someone could come along and deploy that main branch. GitHub Flow tutorial, which Will has kindly just dropped into the Discord as well there, goes into a little bit more detail. Common Flow is pretty similar, but a little bit more prescriptive. So you create your branch off main for your change, and you add your commits, rebasing as you go. Then you create a pull request and discuss and review the code before you rebase one last time and merge that into main and delete your feature branch as well. Common Flow then goes a little bit further than GitHub Flow, defining that releases are marked with a tag and a release branch as well if you need one. And commonflow.org has some details of how to use Common Flow. It's also worth noting that if none of these Git flows make sense to you, you can take inspiration from them. So I don't know of any companies, or many companies I should say, who strictly follow any one strategy. So pick one as a baseline, like I was saying earlier, and then adapt it for your project or your organization. GitHub Flow, I mentioned before, and GitLab Flow, they don't have to be restricted to GitHub and GitLab. But like I say, if you're looking to start with one, maybe start with the one that your Git host recommends, and then tweak that as you go and take inspiration from some of these other flows. There's a great article by GitKraken, which talks about Git branching strategies, the ones that GitKraken supports as well, which I think is actually Git Flow, not GitHub Flow or Common Flow. But there's a great article there that goes into a bit more detail, a bit more comparison about a few more different types of flow. And finally, going to have a look at how we might keep these repos tidy using rebase and merge. We've touched on rebase already by looking at Common Flow, and we'll go into a little bit more on that in a moment. So you've got your branching strategy. This is just a vague example of something that looks a bit like a branching strategy. It closely follows a lot of them, particularly GitHub Flow and Common Flow. But on larger projects with multiple concurrent workflows, you can end up with a real tangle of branches and merges like we can see here. So what are the other options for merging these features? So GitHub provides 3 options for completion of a pull request. We've got the create a merge commit, which does, oh, that's not the right back button, which does this mess we just saw. Squash and merge, and rebase and merge. So let's take a look at squash and merge. Now, some people really like squash and merge, or squash and rebase. It's kind of the same thing. And what happens is your entire feature gets squashed into one commit and then plopped straight onto the develop or the main branch. This is very neat and tidy, I'll give you that, but you lose so much detail. You lose all of that documentation of when, how, and why code changes were made. And I'd much rather keep this history where we can. So although it's a lot cleaner, you don't have that sort of back and forth. And you know I was saying don't hide your mistakes. Well, here you go. Here's a prime example of all your mistakes hidden. So that leaves us with rebase and merge as the GitHub merge options. And this allows us to avoid losing data while keeping the tree clean and tidy. So of course, it's my favorite. If you're using Git Azure DevOps, though, they call this a semi-linear merge, but it's the same thing. Rebase and merge, semi-linear merge, it's all the same. But wait, what's a rebase? So what I'm doing here is this is the Git tree I just showed you a second ago. And I'm going to travel back in time a little bit to before we did those merge operations. So we can walk through how we do it with rebase and merge instead. So time travel back. We can actually leave that yellow branch, that another talk branch, in place because it's already cleanly merged onto main. So there's no intermediate commits on main between where we branched off and where we merged in. No commits on that blue line at all. So it's just the other two branches we need to worry about now. So what I've done is created a new branch from the latest main, and I've phased out that existing Git talk branch. And now, if you've ever done a cherry pick before to move a commit from one branch to another, rebase is kind of like an extreme version of that, except we're cherry picking from Git talk branch onto Git talk branch. So we're told to rebase. Git will cherry pick each commit in a branch in turn and add it to that a new branch, but called the same thing, in the same place. Sorry, not in the same place, but starting from the latest point on main. So in this case, it doesn't have to be main either. You could rebase onto anywhere, but in this case, we're rebasing still onto main where we started from, but sooner. So here I've cherry picked that right talk commit and I put it onto our new branch. So our right talk commit was down here. And what I've done is I've got my new branch up here and put my right talk commit on top. Then we repeat that for the other commits needed. So that's including the fix typos commit, which is, you'll notice, in a different branch, but we've merged it back in. So it's just cherry picking every commit that goes into making this branch. And that's put them up here. So fix typos is now on our Git talk branch. And we've resolved any, what are we doing? We're resolving any conflicts that come up as well. In this case, there's probably not many, but there might have been. So this write another talk might have a conflicting change. So we might have to do a little conflict resolution there, but we do that for each commit one by one. And that's the rebase out the way, actually. So we've cherry-picked each commit, resolved any conflicts, but in a more automated way than actually doing a load of those cherry picks. So if Git can rebase without any conflicts, it just will, and it will run each commit in turn. So now it's time to merge Git talk into main. Which we've done, nice and simple. And we can see that there's no intervening commits on the main branch between when this branch was created and when it was merged, making that nice D shape against the main branch. And actually, this faded out branch doesn't exist anymore now. We've pushed that. We've pushed our new feature talk and main to our remotes. That grayed out branch doesn't exist anymore, so we can get rid of that. And then all we have to do is rebase and merge our final branch, which is another talk. Not another talk. Git article. You can see we've already done these two. We've already rebased these two commits. So when we rebase, we've actually only got this commit to go. So we rebase that, and we've got another nice, neat D shape. And that's what this method of merging does, is it creates these nice little D shapes against the main or develop branch with none of the crossovers we saw before. So you can see it sort of removes that model of crisscrossing branches, but we've still got the whole branch structure and the detail of every single commit. That's been preserved, where it wasn't in the other one. And you can enact this process without using a GitHub pull request as well, or a DevOps pull request. And all you do is you utilize the individual tools of rebase. So you rebase your feature onto main, and then you merge your feature into main in any Git client of your choosing. Here's the command line way of doing that. So we're Git rebasing onto main, the feature /Git article, and we handle any conflicts there. Then we, to merge, we check out main, so git checkout main, and then git merge feature / git article, and that merges it into main. And then we can delete the other branch that we don't need anymore because we've merged. And that's it. That's our stunning archive of software. We've source controlled with small incremental commits, each having a meaningful and detailed commit message, sat comfortably in feature branches with no distracting noise and complicated merges. So it reads easily from bottom to top, and there's no details hidden, and we've not masked any of our mistakes. Now, both tips 4 and 5 go into something a little bit controversial in the Git world, and that's rewriting history. So we're not talking rewriting history as in the act of sort of whitewashing some historical atrocity, but we're simply changing what's been pushed to the Git repository, to the remote, aka history, after it's happened. So we're rewriting. Squashing, amending, rebasing, and patching are all examples of Git history being rewritten. And I've just been actively advocating for 3 of those. So I feel like I ought to explain myself. So maintaining your true history, as I like to call it, has its merits. It's certainly useful for learning and for code reviews, but there's also the risk you might mess up your history if you tamper with it. So it has some merits. However, the way I see it is that this shouldn't come at the cost of the readability of your repo. It's no good having all of that documentation if you can't easily make sense of it. So I prefer to maintain what I like to call my feature history, where the order of our feature development is true, even if we're tweaking the timelines just a little bit of when each feature was developed relative to each other. And I don't advocate for complete rewriting, just these little tidy ups we've been talking about. You might have noticed I said risk earlier. As for that risk, I mentioned when rewriting history, just make sure you've pushed your repository before you start messing with history. Then double check everything is how you want it to be before you do that force push up again. And that's it. Thank you very much for listening. Do feel free to get in touch with any comments or questions. I'll hang around in the Discord afterwards, so do just drop me a message in there. Or you can contact me on Twitter. I'm at Joe Glombek, or Polywork using the name Glombek. I've also got my blog there, joe.gl, and I've written some accompanying articles with some links and some key information as well. Firstly, I wrote an article in Script magazine, which covers a lot of what I've been going through today, and that's the first short link there, go.joe.gl/such-a-git. Secondly, there's a link to the rebase and merge walkthrough we just went through, and that's on my blog, joe.gl. And finally, the details of getting GitLint running as a GitHub action, that's also on my blog, joe.gl. And these are the 3 most recent articles, so it's easy to just go to a nice short domain name for you, joe.gl. But that's everything. Like I say, if you want any questions answered, if you want to tell me how wrong I am, please do. I'm very keen to hear other people's opinions on this. This is how I advocate Git usage, but there are many, many different opinions out there. This is just the best practice I've sort of developed, having freelanced in a few agencies over the last few years. But yeah, thank you very much for listening.